let's move to the third example. Okay, for the third example, we're going to evaluate the integral of x squared minus x plus 6 over x cubed plus 3x. This is actually similar to the third case, no, of decomposition of rational function. The reason for that is we have here a quadratic factor, and that quadratic factor is irreducible. I mean, you can factor out x, and you are left with x squared plus 3 as your second factor, and x squared plus 3 is irreducible as far as rational factors is concerned. Right? So take note that whenever you have a quadratic denominator, your numerator is of linear form. Okay. So I will again do the computation by hand. First, we're going to decompose this, and then after that, finally solve for the integral of this one. Okay. So we have this expression. So we're going to write here the integrand, okay? Squared minus x plus 6 over x cubed plus 3x. And then we factor the denominator. We have x and x squared plus 3, right? Okay, then we rewrite the numerator. Okay. And then there are two partial fractions. And the first one is a over x, corresponds to the first factor. Well, the second one is a linear form of bx plus c, because your denominator is quadratic. Okay, so bx plus c over x squared plus 3. And then combine that as a single fraction. So you have x times x squared plus 3. And then the numerator now becomes a times x squared plus 3, okay, plus bx plus c times the first denominator, which is x. And let's write this in third form. So we have a times x squared plus 3, multiply that, so you have bx squared plus cx, then over x times x squared plus 3. Okay, you can actually cancel that, no? So you have x squared minus x plus 6 equals, you can write that as combining the like terms. So a plus b times x squared plus cx, then plus the constant term, which is 3a, right? 3a. Again, we equate the corresponding coefficients. C, -1, okay? And then 3a equals 6, right? So solving for a, we have a equals +2. And what is b? From the first equation, we substitute that. So we have b is -1. Okay, so we now substitute that to the given partial fractions. So I can write this as a over x, where your a is 2, okay, plus bx plus c over x squared plus 3. Your b is negative 1, and c negative 1, no? So negative 1, negative x minus 1, okay, which is your c. Then over x squared plus 3. And then we put this into simpler form where we can easily evaluate the integral. So 2 over integral of 1 over x dx. Then that's negative, so you can factor out the minus. Okay, you have integral of x plus 1 over x squared plus 3 dx. And okay, to make this integrable, we cannot use 1 over u du because the derivative of the denominator is not present. So let's rewrite this one first. And then I think we separate that as two fractions na lang. X over x squared plus 3 dx. And the other one is minus integral of 1 over x squared plus 3 dx. Okay. Let's rewrite this further so we can still evaluate the integral. Over x dx. Okay, this one here, look at, if this is your u, the derivative of that is 2x, right? So I think let's write it as 1 over x squared plus 3. And then the derivative of your u, the denominator is actually 2x dx. But we don't have 2 there originally, so we multiply outside with 1/2. And then the last one is no matter what we do, we cannot provide the x squared, the du for the denominator. So, but this is of the form x squared plus square root of 3 squared dx. Okay, the reason for doing that is we can use later the formula for arc tangent, right? Okay, recall this one. Integral of 1 over x squared plus a squared dx is equal to 1 over a times arc tangent of x over a plus c. That's for the this particular term. Okay, so we can now evaluate the integral. This is 2 ln of absolute value of x minus 1/2. So the conditions are satisfied. You have 1/2 ln of absolute value of x squared plus 3. Then minus, so notice the formula there. Your a is the square root of 3. So you have minus 1 over square root of 3, right? From the formula. Okay. Times tangent inverse of x over a. So x, okay, over square root of 3. Then plus c. Okay. Let's just write here the final answer in a nice form. So we have 2 ln of x minus 1/2 ln of x squared plus 3 minus 1 over square root of 3 tangent inverse x over the square root of 3 plus c. So that's it. So summarizing again, our solution for decomposition of the rational function lead us to this particular value of a, b, and c, and putting that into the integrand, no? Replacing that, we had this. So this is our final answer. So that's it. I hope you learned something. God bless.